Let's start with the session. So you are here in the session Agile Management Approaches, and I'm really happy because we have very interesting presentations, very interesting papers, which deal with several aspects, with several challenges in using Agile methods for mechatronical systems, for hardware systems. My name is Kristin Paetzold. I think some of you know me because they cited me. How to proceed? At first, let's start with the presentations you prepared. I would suggest we have all the presentations in one line. If you have questions, please use the chat and write down your question and write down who should answer to this question. And after the presentations, I think we can use the questions and we can come into a very interesting discussion based on the presentations. Okay, are there some questions before? If not, then I think we can start. Robert, would you start the presentations?
Yes.
Great.
Hello, my name is Lisa Rößler. Thank you for attending my presentation on the paper Analyzing Agile and Conventional Paradigms for Managing Product Development. In the past years, Agile product development has gained more and more attention in the business world as well as in research. This is due to the common urge to always improve the development of products and also the promises that Agile practices make. For example, that applying Agile practices lead to shorter development times and an increase in customer satisfaction. This is why, as a first step in my PhD project, I wanted to gain an overview over the advantages and disadvantages of the Agile paradigm in contrast to conventional development approaches. The aim of my paper was to share the insights that I got from my literature research. In the next few minutes, I will explain how I proceeded and will then share my key findings. With my literature research, I wanted to find answers to the questions what strengths and weaknesses the two approaches have, and in what aspects they differ from each other. I started by looking for initial search terms like process models in product development or agile product development. I searched in Scopus and found numerous results because there's a lot happening in this field. This is why I tried to narrow down the results through focusing on oft-cited publications and established authors. For example, conventional product development is very well researched. So as a first step, I relied on publications from Pahl and Beitz and Wynn and Clarkson. I also identified Cooper and Sommer as well as Albers and Heimicke as established in the field of agile development. After that, I searched again for additional research. The dataset was then analyzed concerning the advantages and disadvantages of the different paradigms. The approaches that are called conventional during my presentation are represented by development processes that are based on stage gate or are similar to stage gate and have some kind of phases where work is done and gates where decisions are made. Agile approaches all have some kind of circular, iterative process and do not explicitly prescribe what work has to be accomplished at a certain point in the development process. Agile and conventional development approaches have both a long list of benefits when being applied correctly, but they also have an even longer list of disadvantages when being forced in a project that is not fit. So what I found is that, first, no approach is an all-rounder. There is no development approach suitable for every kind of project. Second, the approaches always have to be evaluated in a certain context, that is, according to a project's characteristics and environment. Third, most problems can be traced down to false application. For example, false implementation of practices, but also, like I mentioned before, forcing the wrong development approach on a non-suitable project. And fourth, the strength of one approach is not necessarily a weakness of the other. So when comparing the two paradigms, it becomes apparent that there are not just advantages and disadvantages, but rather contradictions because of their differing mindset. Some opposing factors are, for example, the approach, including the goals and the environment of a project, but also the execution, that is, the application of a certain practice or method and its implementation. They also differ in the management, for example, management style and decision-making, but also change in risk, that is, openness to change and how a method is able to adapt to change. They also differ in their interference, for example, how a method interferes into the process, and their interactions, that is, the interactions between the team and the management, and also the interactions with a customer. So as a next step, those factors have to be further analyzed to enable development engineers to decide which approach is suited best for their project. You can see here an example how this can look like. To highlight one aspect concerning the overall approach of a paradigm, please have a look at the point size. Conventional approaches, for example, are better suited for larger teams and larger projects, while agile development approaches are better suited for smaller teams and smaller projects. As the many contradictory factors that influence product development show, a development approach must always be adapted to a project's characteristics, as well as the business and organizational environment, in order to increase the chances of developing a successful product and a successful development process. So just like projects differ from each other, a development approach also has to be adapted to the size of a company, to the level of maturity in project management in a company, to the technological uncertainty, to the scope of a system, to the degree of innovation, and also, like mentioned before, the size of a team. Thank you very much for your attention.
Thank you for the presentation. So if there are some questions, please write it at first in the chat and we can use this backlog later on. Then let's go to the next presentation.
Hi, my name is Jake Drutchas, and I'm really excited to be presenting my paper today from MIT, providing guidance on the application of Agile in combined hardware and software projects, which I wrote with Professor Stephen Eppinger. And this paper is advancing our knowledge on applications of Agile outside the realm of software. Let's start with the myth that hardware is so different that Agile development methods can't work. The reality is, and what our research has shown, is that Agile works for all kinds of projects. It just takes adjustments. And that's what we're excited to be here presenting on today. Adjustments to challenges in applications of Agile and hardware. And I want to begin by discussing Agile itself. As we all know, it started over 20 years ago in software, and benefits are driven by this iterative cycle of sprints. But also, over the last 20 years, Agile has seen quite a lot of changes as teams work to adapt and adjust Agile to fit their needs. This process started with software, but it continues and it's happening in hardware. We're not the first to look at this topic. Several researchers have pointed out why Agile is difficult to apply to hardware projects. In particular, we found the 2019 paper by Atzberger and Paetzold to be especially insightful. They lay out a number of constraints related to the physical nature of hardware, which makes Agile so difficult. For our research, we are focused on 3 key challenges and adjustments that teams are actively using to overcome them. These are the challenges of sprint cadence, physical constraints, and backlog decomposition. To review our methodology and how we got here, we interviewed 8 different companies ranging across industries and work streams. Every one of them combines hardware and software. All the teams we interviewed also have experience working with Agile. We began by interviewing, collating notes and key points, We then affinity mapped them to find patterns and themes, which we use to define our key learnings. Our results were those 3 key challenges, as well as what teams are doing to overcome them. The challenge of sprint cadence centers around the concerns team have accomplishing work within the conventional 2 to 4 week sprint process that's recommended by Agile. Adjustments being made are using decoupled sprints, which is allowing different teams to select their timing for sprints. Grouping sprints is when large work efforts can't be broken down into a reasonable short sprint period, then grouping multiple sprints around that and having that large effort be accomplished within this grouping. And lastly, Kanban is allowing some teams to use the Kanban methodology. The challenge of physical constraints is the challenge of making changes in hardware, and the fact that it's just not as easy to change or make updates as it is in software. Adjustments teams are using are moving more towards reviewable increments and getting away from this notion of a shippable increment. Reviewable increments is more aligned with what are key learnings that you can bring back to the table, to the team, which improve future efforts. Risk reduction is another adjustment, which is structuring the backlog in terms of uncertainty and risks that the project faces, and prioritizing using the notion of risk. And lastly, the challenge of backlog decomposition, which is the frustration teams have when faced with trying to decompose hardware efforts into incremental and reviewable parts. And for this adjustment, teams are using integration points, which is allowing this process of divergence and convergence across the teams, and really purposely planning in and coordinating interface points, which allow for key learnings to be brought together to, again, inform and improve future efforts. And to give a couple examples of a few of these adjustments, starting with grouping sprints, in talking with a mobile IoT platform team, they talked about how when they're faced with larger efforts, they use this process that they call iterations. And iterations are a group on average of 3 sprints. Each sprint then does not have a shippable increment or a outcome of the sprint beyond the fact that they still use the sprint structure. So there's still a sprint goal. They're still working through their backlog and continuing to improve the backlog to inform and improve future efforts. But the outcome of the larger effort comes at the end of that iteration. On the challenge of physical constraints and the risk reduction adjustment, Bressel Group, which is a product innovation consulting group, uses this methodology when working through projects. They prioritize the backlog in terms of project risk, and then as the backlog develops over time, they work to contain these risks and bring key learnings back to the team. And the focus is on answering these large questions that relate to these risks and uncertainties. And lastly, on the challenge of backlog decomposition and building in these integration points, Bo's hardware development process works to plan these integration points across the entirety of their development lifecycle. And so these are points where they're bringing together all of the software and hardware teams and really focusing on bringing what is the current state of all of their efforts so that they can understand the current status and what critical elements remain. And they use those integration points to inform their future work. And so in summary, while most organizations today still aren't using Agile, there are many teams getting Agile to work in hardware. And the secret seems to be to not have to apply Agile the same way that you would in software. Adjustments allow for Agile to be customized to work for each team or each organization. And so what does the future of Agile look like? Agile is still evolving and expanding, moving beyond software and hardware and into new industries and areas of work, such as healthcare, construction, and more. And so for future work, we're excited to continue researching this changing landscape, thinking through how to quantify the benefits of change, how to support teams in making these decisions around adjustments, and how to work to better understand when an adjustment is beneficial or not. So with that, thank you.
Thank you for the presentation. Really nice. Let's go to the next presenter. This would be, oh, sorry, I lost. Johannes Mueller from KIT in Karlsruhe, introducing agility into the process of manufacturing companies. Please.
Hello, my name is Johannes Müller, and I'm here on behalf of IPEC, Institute for Product Development from Karlsruhe Institute of Technology. I'm pleased to present you our paper, Introducing Agility into the Process of Manufacturing Companies, a method for evaluating success, support, and applicability. So first of all, I would like to start with a little motivation. Let's imagine two situations. In the first situation, a development team wants to reduce the work overload of team members by using agile methods. In the second situation, a development environment wants to improve the customer involvement through agile methods. So these situations are very different, but can both be addressed with the use of agile practices. But how can we validate if the agile method is delivering the desired benefits? But first, we have to take a step back. There exist countless agile methods and frameworks that can be used to meet the described challenges. Examples are design thinking, Scrum, and SAFe, with countless more not listed here. So how do we know which one is the best to use in our situation? That's why we developed ASD, Agile Systems Design, to introduce agility in mechatronic systems development systemically. ASD is based on 9 fundamental principles. Here we're going to just talk about 3 of them to give you a little insight of ASD and its fundamental idea. The first principle is each product development process is unique and individual. In practice, not 2 product development projects are exactly alike, as each project is carried out within a project-specific context. This leads to the fact that no specific product development process exists, which is valid for 2 or more different development projects. That means that there's not the one agile framework or method that helps everybody solve his problems. Next, agile situation and demand-oriented combination of structuring and flexible elements. Structuring and standardizing elements help development teams to orient themselves in complex situations that are characterized by instability and unpredictability. At the same time, successful handling of complex situations requires a high degree of flexibility in order to adapt the procedure on the basis of knowledge gained or changed environmental conditions. The last idea, all activities in product engineering are to be understood as a problem-solving process. The trigger for the execution of each activity of the product creation is the deviation of an actual state from a target state. Actual, target, and the path from the actual to the target state can be partially or completely be unknown. The activities of the product development serve to activity-specific actual state into activity-specific target state by means of activity-specific operations. So now the methodology that operationalizes ASD can be described with the following figure. The first 2 steps, situation analysis and problem definition, are used to define the target system with the help of fields of action and factors that describe the operation system. In the next steps, process solutions are proposed and selected based on method profiles that are developed dependent on steps 1 and 2. In the last steps, the method is introduced and the performance is continuously measured to optimize the introduced method. So much about theory, but how do we ensure that the ASD method works and at the same time prove that the introduced method performs as intended? We do this by answering the following research questions. How should a systematic be designed that evaluates the method for introducing agile elements analogous to the agility concept of the ASD, Agile Systems Design, into the process of mechatronic system development? And which statement can be made regarding success, support, and application of the method for the situation and demand-oriented introduction of agility following the developed evaluation? In order to verify the success of the individual steps, we use different interview guides to survey the users of the method. Each interview guide is used to measure the success of a different step. But it's important to note that the ASD method is performed continuously, and so are the interviews. During the research, we conducted 3 industrial case studies in a company that produces audio technology, a research institution, and a big machine tool manufacturer from Germany. So now here you can see the full process of the ASD method. However, it's not important to talk about every small step, but rather about the superordinate process steps. During the first step, the situation capture, the first interview guide is dispatched. During the derivation of the method profile, we dispatch the second interview guide, followed by the third interview guide during the evaluation of the method profile. During the evaluation of the project, we use the user questionnaire, followed by interview guide 4 during the success management. But enough about the process, let's talk about the results. The interviewees could spread 1 and 4 for every question, with 4 being the best value. As you can see, question 2.3, understanding the individual objective before introducing agile elements, scores a 4.0, meaning that the support evaluation is successful. Question 2.12, which scores as 3.7, affirms that the procedure from the selection of context levels and fields of actions makes sense in order to sharpen the goals for the introduction of agile approaches. Furthermore, the question if the development process was improved scores as 3.3, affirming the success evaluation. Using an interview guide additionally allows us to capture qualitative suggestions to improve the process. So now, what's our conclusion? Each use case of the introduction of agility is individual. Existing evaluation approaches from a DRM, the design research methodology, are used to adapt the evaluation to the implementation success to the individuality of the case. For this purpose, we use different survey methods in order to determine various evaluation criteria, success, support, and application evaluation at different points in time from an operational and strategic point of view. Regarding future works, we need to further develop type and number of criteria and have to focus on usability regarding the formatting of the evaluation process, as it turns out that using an Excel template is not the most user-friendly way to conduct interview studies. After that, the only thing that's left for me is to thank you for your attention, and now we are open for questions.
Thank you. Okay, let's start with the next presentation. I think is Camilla's presentation. Yeah.
My name is Camilla, and I will present some key points from our paper about the use of prototypes to increase agility in hardware development. Now, this research was not motivated by a special interest in agile methods, but rather from our interest in prototyping and how, when, and why prototypes are used in the design process. We observe how designers use prototypes, such as these ones that were made in the Mechatronics design course at DTU, to design new products. For instance, here you can see the prototyping process that went into making the final prototype for an ultrasound coffee brewer. In our observations, we've noticed that the existing prototyping theory is sometimes a little too simple to sufficiently describe the prototyping process for such complex hardware products. For instance, the prototyping process is often described as an iterative cycle, like the one you see here on your right. And while this model can describe part of what is going on, we have experienced that it is too simple to guide the management of prototyping in design. In this research, we therefore took inspiration from Agile theory, which also uses this iterative approach. In the first part of the research, we adapted the Agile Scrum sprint, which is known from software development, to the prototyping sprint that you see here. The sprint consists of a prototyping cycle with multiple prototype iterations, which leads to the development of a prototyping milestone. Before the prototyping cycle begins, it is a planning phase is completed and a strategy is made for how the prototyping cycle should be carried out. And after the prototyping milestone has been made, it is formally reviewed by stakeholders. With inspiration from the Agile stage-gate hybrid model, we also describe how the prototyping sprints are used continuously across the different phases of a design process. In the second part of our research, we compared the two prototyping models that we've just described. The simple iterative prototyping approach to the left, and the new, more advanced prototyping sprint to the right. And we did this in a 3-week mechatronics design course. In the course in 2019, we had student teams follow the iterative approach with no requirements for how many iterations to complete before they delivered the final prototype. In the course in 2021, we divided the project into 3 separate 1-week sprints. In each of these sprints, the team should plan the prototyping cycle and review the prototyping milestone that they completed in the sprint. And to support these 2 different prototyping processes, we gave the student teams some specific prototyping tools. In 2019, the students used a tool called the Prototyping Planner, which is a template that supports the planning and evaluation of a single prototype iteration at a time. In 2021, the students also used the Prototyping Planner for each of the iterations. But in addition to this, they used a tool called the Protomap to connect and create an overview of each of the iterations. The Protomap also helped them to plan and review each prototyping sprint. And here you can see an example project from each of the courses. To the left, you see the different prototyping planners that led to the development of a spice dispensing prototype. And to the right, you see the Protomap with a number of different prototype iterations leading to the development of a waste sorting machine. When we compared the teams' prototyping processes, we could see that the teams that used the prototyping sprints prototyped more and iterated more overall. We also saw that they divided the product into some clearly defined subsystems, and that they prototyped more within each of these individual subsystems. And finally, we saw that they also used prototypes more to test the integration between different subsystems to ensure that the whole product worked as intended. And we saw these tendencies across all teams. So overall, this indicates to us that the teams that used the prototyping sprints had a more strategic prototyping process than the teams that used the simpler iterative approach. The teams were also asked to present their design process on online blogs, and therefore we also looked at which words the team used to describe the process and their use of prototypes. All of the teams used many words related to the fabrication of the prototype, such as motor, sensor, code, etc. But we saw a large change in the number of words that were used to describe the prototyping strategy. The teams in 2021 that had used the prototyping sprints used substantially more words to describe the strategy around the use of their prototypes and how their prototypes contributed to their overall projects. So overall, it appears that the use of prototyping sprints made the teams more aware of their prototype decisions. To conclude, the first part of this paper introduced a prototyping sprint, which is based on the Scrum sprint that is used in software development. And here it's important for us to note that we don't see this as an alternative and individual framework separate to Scrum, but rather as a specification of how prototypes can be used to drive agile hardware development. Secondly, we compared the prototyping sprint to the traditional iterative prototyping approach, and we saw that student teams that used the prototyping sprint were more aware of their use of prototypes and used more advanced prototyping strategies in their design projects. But future work should, of course, investigate the use of prototyping sprints in longer projects and in an industry setting. If you found this presentation interesting, you can read more in our paper. But thank you so much for watching.
Thank you for the presentation. And the last presenter will be Mr. Reichelt about a new holistic approach towards a technology-driven development model in automotive. Please.
Ladies and gentlemen, my name is Florian Reichelt, and I'm very pleased to present our latest research on a new holistic approach towards a technology-driven development model in automotive. After this short introduction, I'm going to give you a short overview over the hybrid methods or different types of hybrid methods. Then I'm going to present two main parts of our new holistic approach in automotive, and I'm going to finish my presentation with a short conclusion and outlook. As you just heard, and I guess most of you know, there are different types of methods in both project management and product development. I'm not going to give you a detailed overview over the differences regarding the characteristics and the circumstances of each methods of agile and traditional, but I'm going to give you a short hint. So the agile transformation, which is one big part in the last decade for many organizations, is showing up more and more limitations as further the transformation went, and both literature and case studies show that hybrid methods seem to be the most promising solution to successfully implement agile methods into especially hardware-oriented and classical-oriented organizations and development processes. But hybrid methods are very different. So there are, as you can see on the right-hand side, there are different types of hybrid methods, and you can distinguish them by special regard to the type of combination. So first of all, there's the sequential combination, having an agile starting in your product development and then finish with a traditional and phase-oriented product, for example. Then we've got the parallel use of both agile and traditional methods. And on the one hand, we've got the simultaneous use, so having both agile and traditional methods. And these two types are quite similar, having one predominant type of method set, for example, traditional phase-oriented method set with some components or value streams using the other method set, for instance, using here agile methods. The most occurring types are these two types, so the simultaneous use and the implementing or point-wise into implementing of agile methods in a very traditional surrounding. Around about 95% of all hybrid methods published in the last years are of these two types. And there are issues by using these types of hybrid methods. First of all, these types don't beneficial the benefits of each method. So there's unused potential, and especially with regard to the early stages in PD, there are different circumstances, and these are not addressed by using these types of hybrid methods. And therefore, we derive a new holistic approach in automotive, which is first of all a theoretical approach, and we separated the technology development and the product development in two streams. And first of all, we've got the technology or the tech streams. And in these tech streams, there are multiple tech streams which are focusing on the development of new technologies from scratch, and they are following a technology roadmap which sets different goals. And due to the mainly agile character, there are different types of maturity levels. And if there is a certain technology readiness approved or reached, the results of each tech stream can be implemented into the classical product development, the so-called technology pull. And why do we choose these Czech streams to be agile and object-driven? That's because the mainly purpose of these streams is to develop new technologies from scratch, and which means that this is a high uncertain development area, which on which agile methods have the most benefits. On the other side, we've got the shortened product development, which is mainly oriented on classical PD processes, and we're using the inputs from TechStream, which can occur on different phases, and they are going to be implemented in a classic-oriented product development, which is lastly very product-specific, and of course very individual process. For each module, it's an individual process, but it is significantly shorter due to the fact that the strategy part, the definition of the product, is right at the beginning, and there's no early stages, no technology development in front. So last but not least, we derived an approach which is very context optimized. It is an holistic model to target common problems with the implementation of agile methods. And what's our outlook? We are currently in the phase of implementation and evaluation of the new model, and as one result from our evaluation, there's a significant need for an edit for better decision making, and we need to expand our research, especially on the design technology convergence, which is one of the main parts in the early phases. And so far, thank you very much for your attention, and I'm looking forward for your questions. Thank you.
Okay, thank you for the presentation. Thank you all. Let's start with the discussion. I would start with the questions we have in the chat. Okay, and the first question was from Lisa to Jake. Often engineers work in 6 different projects simultaneously, which is not very agile. First question, why? Okay, how did the overall organization and the companies look like? Did they have to change the organization to enable agile work? Jake, can you answer?
Absolutely, and thank you for the question, Lisa. Yeah, so a great question, and we've seen kind of a mix of things. We've actually even seen organizations that have part-time agile teams who are doing, 1 week a sprint on one topic within a month. And we saw a mix within the organizations that we were working with, and quite a few that have explored things in the past. For instance, we worked with Ford, and the Ford team that we worked with had tried multiple models to figure out what best worked for their team. So I think it's a great point and an interesting dynamic that is also an adjustment that teams are actively working through.
Okay. One question in this context. In your study, as you said, you made an industrial study, and you have some companies. And do you have any correlation between organization size and the size of the organization and the kind of organization and the effective use of agile methods? Do you investigated such points?
Then that's a question to me, correct?
Yeah. Sorry.
Yeah, absolutely. So we actually wanted to explore companies kind of across industries and across size of organizations. So on the large side, there was companies such as Ford or Bose, and then on the small side, there was kind of growth stage companies. And the correlation was just around the projects that they were working on being combined hardware, software, with some dynamic of the team having agile experience and working through agile. And so that was the main factor that we were selecting organizations on. We weren't looking for kind of patterns between those things of that nature.
And how many companies you investigated?
We interviewed 8 companies.
Okay, thank you. There's another question to you. Thank you for the present. I would love to hear a bit more about what you describe as interfaces that represents points of overlap between various sprints across teams and any best practices you identified there.
Yeah, that's another great question. And again, a mix of kind of contributing components within that. Within some of the smaller teams and smaller organizations, by having team members be more co-located, there was a lot more just kind of free flow of information across team members. On the larger side, though, looking at an organization like Bose, they had very specific planned integration points where they knew at this kind of phase of the project, we were going to bring everyone together and put all of the parts and pieces to see what the status was. There's another electronics company that also used specific team members. They had assigned one team member from each Agile team, and every week they all got together to discuss key learnings, key risks, key issues, key things that would potentially impact other teams. So quite a few ways of looking at these interfaces and trying to find ways that help improve their process or model.
Okay, is this okay? I don't know. From my point, it's okay.
Yeah, Vivek, does that answer your question, or do you want me to get into more specifics? Also happy to talk about it.
It's a question to the guy who asked. One question. We have in the presentations, we see 2 approaches to analyze all these challenges in using Agile methods. Lisa made a literature study, and Jake makes this study with companies, and I think the study from Johannes was also directly with companies. Do you see, or when you compare your results, do you see significant differences, or what is your feeling? Are they the same results in these several focus areas to collecting data?
Yeah, again, I'll take a first stab, but if any of the other teams want to hop in on this as well. I think what we're seeing is that this is still the age of experimentation, and teams and organizations are actively exploring. And so while it seemed, I think, on kind of first blush that Lisa's research kind of brought out a different perspective, I see it as kind of a both-and situation, with teams actively exploring different situations and trying to figure out what's going to work for them and what the future of their work looks like.
So I would like to say something. So what I found out that every project is unique and that you have to adjust the development approach to the project. I think I found the same in the presentation by Johannes. But I think the question is now, do we really have to adjust the development approach to every project, or would a hybrid approach be the solution, like we heard in the last presentation? So I think this would be very interesting in the future to see which way is going to be further proceeded.
Yeah, that's right. Johannes, your approach, what do you think? It seems to be also kind of hybrid approach. Can you identify one of these models with Florian represented?
Yeah, of course. In our experience, we prefer the combination of agile elements and structuring elements that we have in the existing process they use. And I think it's quite similar to the approaches Florian presented to us, that we have the underlying process that is established in the company, and then we add agile elements and agile method fragments to this. And through adding these methods or pieces of methods, we try to optimize our process, but not overhaul it at one point. Just say, let's use Scrum and everything is going to be fine. But
in small steps, adjusting with method elements.
Some other comments? Okay, if not, we have some more questions to Camilla. That was also a very, very interesting approach. Prototyping is a very interesting and a very important tool for Agile methods, and therefore there are a lot of similarities, and I think we can learn a lot from your research for Agile methods. Some questions here. Did you define beforehand how big adjustments should be to require a new prototyping planner and therefore new iteration?
Yeah, thanks, Lisa. I think this is a really good question because this is something we have thought a lot about in our prototyping research, is what exactly is a new prototype or a new iteration? And it's really hard to define because it is this fluid process almost. So we didn't define to the students here how much they needed to change to make a new prototyping planner. It was up to themselves that when they thought that this was a substantial difference, a new version of their product, they should make a new prototyping planner. So that also meant that some teams, they made a lot of prototyping planners and defined a lot of iterations, but other teams only made a few selected ones. But this is also where I think this Scrum-inspired or Agile-inspired process is a better process to describe prototyping, because it has this, a big cycle leading to these milestones, but a lot of small cycles of smaller iterations going into creating this big milestone.
Mm-hmm. Is this question answered enough? It's difficult to get any feedback from the...
Yes, but was there a difference between the teams who made a lot of iterations and fewer iterations? Was one better or not so good?
I would say that the teams that made fewer, maybe they didn't make fewer iterations, but they used the prototyping planner list to describe their iterations, I would say. So those teams, we had not as good an understanding of what they'd actually done than the other teams. Yeah.
Mm-hmm. Thank you.
But this leads to the question, are you able to identify the knowledge base which these teams have in solving the problems?
Sorry, what was the question?
So the teams with more iterations, that's only a hypothesis. Maybe they have a bigger knowledge base, or they are able to build up a knowledge base because they tried. Prototyping is always try and error principle behind, and this means you learn with this process. Can you make some conclusions about the knowledge base or the knowledge development in these groups?
I would actually say that it was more about how, maybe not so much about how much they iterated and their knowledge base, but more a reflection of how structured their approach was and how willing they were to use these structured approaches to prototyping. So I think if we look at detailed at their process, they could be quite similar, but the ones who didn't have used the prototyping planner as much, they just didn't have a structured approach to their process, and kind of maybe forgot a little bit about using the tool to structure what they were doing, and wanted to do it a little bit more just casually in their own way.
Okay, thank you. There's another question to you, Camilla. It seems that a little process goes a long way. Would you attribute the benefit of sprints to beat the explicit planning stage, or the strict weekly sprint cadence, or the review and retro?
Yeah, I agree with this a lot, that just a little bit of a difference or a little bit of a different process makes a big difference. And I think the really key difference here is the sprint cadence. So the big difference between the two courses was, in the first one, we said to the students, you have 3 weeks to deliver this or present your prototype in the end. And in the other course, we divided it into these 3 sprints. And this makes a really big difference, that they are working towards these sub goals instead of this really big goal in the end. And with that also comes this natural, it becomes natural to do the planning and the reviewing when the project has been divided into these sprints from the beginning. So I think that's really what makes a big difference.
Okay, some comments? So
yes, additionally, just a thought, but this is some similarities we find in our research, that having just pure Agile is something very, very different, especially for having a very clear product or clear vision of a product with clear steps and sub goals. And just neglecting these types of structure, even or help for the developers, just means that they lose their focus, and therefore there needs to be some guidance. And as your research just show, little changes or little planning in Agile just pushes the quality of the overall quality of your prototypes or even the product itself.
Yeah.
But I think we have to distinguish a little bit, because Camilla, as I understand you right, you make the prototypes to create a functional system at least at the end. They get. Can you explain? The students get the task, and they have found a solution for this task, and this should not only be a sum of drawings. That should be something which is working.
Yeah, the task, it was the same for the two courses, that in the end they would have this sort of functional prototype to demonstrate their idea.
To demonstrate, yeah, because my idea was we use prototypes in agile development processes also to check or to validate, do we do the right things? Yeah. And therefore, sometimes it's good and helpful to have a physical model, but often it's enough to have, for example, a simulation or something like this. And the question is, which prototype is good? It's a question of which information would I give to the development team or to the customer. Yeah, and I think this is not what you deal with.
No, it's not. This was more of the structuring the process. But what's important to note here is also that, I mean, they delivered this final physical prototype in the end that demonstrated their entire idea, but they used prototypes, small iterative prototyping approaches every day during those 3 weeks. So they also used drawings, they also used simulations when that made sense. And they also went out and got feedback from some potential users. So they did a lot of these different small iterations leading up to that milestone, as I call it, in the end.
Yeah, okay. So it's not a focus, but very interesting. Okay, another question to you. How representative do you think the as-recorded prototyping activity in Protomap is of the as-done prototyping activity?
Yeah, this is also an interesting question so every time we make these tools and we ask the students to make these representations, of course, there will always be some difference between reality and what they recorded. But I would actually say that the Protomap is a really good way of recording the process, and it is pretty accurate. So first of all, the Protomap is pretty, if you compare it to the prototyping planner, the Protomap is very quick to kind of add something into, and you can easily capture a lot more of these iterations, you capture a lot of the data of the process quite easily in the Protomap, and the students are more willing to use that during the process. They can be with the prototyping planner because that takes a while for them to use, so it's a little bit more of a hurdle. So in my experience with the last couple of years, we've used the Protomap in different projects, is that it's a quite good tool to capture the prototyping process, and it gives a pretty good picture of the real process.
Okay, some comments. I think this question was a little bit related with the next question. Where there are any significant differences in prototype planner V2 used in 2019 and V4 used in sprint 2021?
Yeah. So like along these projects, we have been working with the prototyping planner and also tried to improve it along the way. So there are some slight differences between the versions that were used in the two courses. But so the differences are mainly in like the structure of the tool is the same, but we have been focusing on making it more intuitive and simplifying it a lot. So the one in version 2 in 2019 had more questions, had more details to it than the one in 2021. And the reason we also did that was Philip commented in an earlier session today that he's also experienced that people find it time consuming to use a tool like the prototyping planner. So we really focused on simplifying these tools so they don't become a burden. They shouldn't be seen as like a big documentation tasks to the users, but they should also be seen as something that can help them decide which prototypes to make during their design process. So we really wanted to make them very easy to use and intuitive and in a way that they could be easily incorporated into the students' design processes.
Thank you. Are there some more questions to Camilla? If not, then we have a question to Florian from Stephen. Interesting to see such a range of hybrid agile traditional models. We have also seen another one in which the earlier concept and the system architecture stages are done in traditional mode and then followed up by many parallel agile teams working on detailed design, testing, integration. Do you have similar experiences, Florian? Or how can you use this approach in your concept?
Yeah, thank you very much, Stephen, for your addition. Well, that's really one other point for combining agile and traditional methods. In our case, we focused on the automotive sector due to the high quality standards, which are mainly developed in the latest path on phases in product development. They are mainly driven by strict and traditional methods, and therefore we neglected this type of combination of hybrid. But yeah, indeed, these parts or this type of kind of hybrid approach exists, but in the case, or in this special case of automotive industry development, we don't see it at this time because there are strict quality levels and processes like NCAP, and on which the classical PD is oriented at, and there are defined quality gates which have to be taken at the process of product development. Yeah.
There's another comment. We have seen 10 cases or so and many different patterns of how they are combined, some early phases in Agile, but a variety of patterns. So Emma, would you explain your comment? Okay. Okay, Stephen has answered. I don't read it. Okay. Nevertheless, Florian, you had a lot of several models to connect agile and traditional approaches. What are the criteria for using these models or for defining these models?
Okay, interesting question. Well, we just derived these types of models from literature and the results we found in literature or in case studies. So it's not a criteria-based distinction we made, but we see or we saw in the industry. And I think that's kind of linked to Sima's question or statement. there is, for our point, there is no best solution of combining hybrid approaches. So I guess we all know the different challenges by using or implementing Agile, and there are more requirements and more restrictions which have to be faced, and therefore there are multiple criteria for all companies, and the company has to find their perfect match to use Agile and traditional methods. But in our case, we step back and say to use both benefit. Lisa pointed out the different stages or different benefits and strengths and weaknesses of each concept. But we derived our approach or our model to focus on really taking both benefits of additional, and therefore we choose the not simulate the sequential combination. Yeah.
Okay. Saima is here now. Now she can comment her.
Yeah, sorry, my apologies. I was just trying to get the camera access. Now, my comment was related to that we've been looking at 10 different cases. So we've been in industry rather than student environments. We've seen multiple ways of combining with stage gates. So that was my comment, and not one single pattern. I have to go back and read the papers here because they sound very interesting. So that's what the comment was. I was commenting back on Stephen Eppinger's comment, where he was talking about the stage gate being used in the earlier phases. And I think 2 or 3 of our cases did the opposite, where they're using Agile while you could keep changing requirements and be very fluid. Mm-hmm. And then as soon as the requirements are locked, then they're using hybrid of stage gate and Agile. But I've seen multiple patterns. So I've seen at least 3 or 4 different patterns. So that was the context of the comment.
Do you investigate criteria to distinguish between these patterns?
Yes, so I'm trying to create a model right now, or several sets of models based on these case studies to look at how they're combined. So I think one of it's around the design freeze, like when do you freeze requirements? And so you go into one or the other. And the other is where they, so it's interesting, but the whole discussion of prototyping is, if you're coming from, it's working out the complex bits before moving forward, and that might be, and so there's different reasons. I won't say I have an answer to them, but I think I need to read all these papers to see what other patterns they are that are emerging from them.
Yeah. So one effect we learned in our research is the knowledge about Agile methods. So we have a lot of companies with a regular study, and we see that the companies learn to deal with these Agile methods. They adapt it to the specific content in the company, to the specific context in the company. And with this learning process, our feeling is there's also a kind of change in these patterns of hybrid models. Yeah.
Yes.
Maybe that can be also an interesting approach to look for these dynamic effects in these combining Agile and traditional methods or procedures.
Yeah.
Main part is the kind of product you're going to develop. So there are different types of just adjusting your product, or some kind of in German you call it Modellpflege, so like a facelift. So you adjust your predecessor model to a new market situation, or you're going to develop a fully new product. So I think this kind of project type is going to to be a main kind of main criteria to select the hybrid combination. and of course the need of your different value streams or compartments which need to interact with each other during the PD. Also in criteria for selecting the combination of hybrid methods.
Okay. Okay, there is again a question to Lisa. While researching the literature for your analysis, did you implement one of the Agile approaches you mentioned, Scrum or AIM for literature review and analysis?
Actually, I'm not really sure how to understand this question. I myself have the opinion that an agile way of working can happen on every level. So also on the level of every individual person in their daily work life. So if this is the question, yes, I myself think that I work rather agile than conventional, but I could not say that I follow a certain approach like Scrum or DevOps. No.
Okay. Okay, so are there some questions? So one thing, or one kind of question, I don't know. In Jake's presentation, he dealt with these aspects of sprint cadences and backlog decomposition and so on. Is this not the kind of scaling problem you address? And I think these scaling aspects are addressed in some of your presentations. The necessity to scale agile methods, because we have a bigger organization than normally in software development. We have a bigger task. We have to distribute this task. We have to separate this task and so on. And the scaling effects, maybe, what do you think? Is this important to think about how to distribute, how to separate the tasks and the sprint cadences at least? That's a question for all. I don't have any answer. Oh, sorry. Florian, the connection is very bad. I don't know, maybe you switch out the monitor.
I can take a stab as well as Florian figures. Yeah, I think it's an interesting point, and that's, I think how we've been thinking about this is that as organizations scale, as projects scale across organizations, that's really the role of having these interfaces and integration points. And as this organization scales, you lose the ability to kind of organically compose those. And so in Scaled Agile, that's why it kind of more formulates what those look like and when they happen and where they happen.
Okay. Are there some more opinions? So if not, sorry. Thank you for the very interesting discussion. It was really inspiring for me. I hope for you too. Robert says there is the social gathering starts at 70:30. So yeah, I think we should end this session now. Thank you all for the presentation. Thank you all for the discussion. Really nice, really inspiring. And maybe we have some more discussions on the next conferences about this topic, because I think there's a lot of potential in this necessity to research in this topic. And yeah, there are some interesting approaches, and it will be interesting to see how they develop over the time. Thank you all.
Thank you.
Thank you.
Okay.
Thanks, everyone.
Bye.
Bye.